Okay, we're still in section 2.3, factoring quadratics. Yesterday, we learned how to factor the difference of squares. So you have a binomial, which means there's two terms, and it's a difference, so subtraction, and then each term, each of the two terms is a perfect square. And the way we factor these, just to review, you look for a GCF first, which this one doesn't have one. Then you go to your two sets of parentheses. Then you take the square root of the first term, so the square root of x squared is x. Your signs are always plus, minus. And then the square root of the last term, square root of 25 is 5. And that would be your factored form there. Okay, for this one, just another review problem. Look for a GCF, so is there any number that can divide into both 9 and 16 evenly? No, there's not. So I'll skip to the next step, which is writing the parentheses. Take the square root of 9x squared, which would be 3x. Signs are always plus and minus. Square root of 16 is 4, and that is the factored answer. Okay, so that's the difference of squares. So that was the first factoring method there. Let's go, today we're going to learn the second factoring method. So this is factoring a quadratic trinomial. So a trinomial has three terms. So here's our learning target for today. I can factor a quadratic trinomial. For today, in our trinomial, our a term is going to equal 1. So when a equals 1. And then tomorrow we'll look at when a is greater than 1. So let's just review. Standard form is ax squared plus bx plus c. Okay, so when I'm saying that the trinomial, when a equals 1, that means this term in front of x squared is just 1. So it would be something like this. X squared plus 5x minus 14. So let's look at that problem first. So if I wanted to factor this, I know it's a trinomial because it's three terms, 1, 2, 3. A is 1. There's no number in front of the x squared, so we assume it's a 1 there. So this would be a trinomial when a is 1. All right, so how do we factor this? Here's our success criteria. So first, just like yesterday, you want to check for a GCF. Check for a GCF first. So I have the numbers 1, 5, and 14. Is there a GCF for those three numbers? No, there is not. So now I can go to step 2. And now I'm going to list the factors of the C term. So in my problem, A is 1, B is 5, and C is negative 14, okay? So my C term is negative 14. So I'm going to write negative 14 over to the side, and I'm going to list all the factors of negative 14. So I could have negative 1 times 14, or I could have 1 times negative 14. I could have negative 2 times 7, or 2 times negative 7. And that would be about it. That's all the factors of negative 14. So after I do that, I'm going to circle the factors that add to the b term. So that would be here, 5. So our b is 5. So I'm looking for which factor adds to 5. So -1 plus 14, that equals 13 if you add them together. That's not 5, so that doesn't work. And then this would be -13, that doesn't work. -2 plus 7 is 5, so this one works. So I'm going to circle this, okay? So I was looking for the b term, so I'm circling the factors that add to the b term, which is the middle term. Okay, so I got it, -2 and 7. Now I'm ready to write my answer, so I'm going to write my parentheses. And if I had a GCF, I would bring that down as well. I don't in this case, but if I did, I would want to remember to bring down the GCF. Okay. All right, step 5, we're going to square root the a term and put it in the parentheses. So square root a term and put in parentheses. Okay, so let's go back up here. My a term here is x squared. X squared. So the square root of x squared is x. So I'm going to write that in my parentheses. So I've got my parentheses. And then I'm going to take that x, and it goes here and here. Okay, so A. All right, now I'm ready to finish it up. So to do that, I'm going to finish the problem by putting the circled factors into the parentheses. Finish by putting the circled factors in the parentheses. Okay, so I've got -2 and +7. So those are going to go in my parentheses. -2, +7. And this, my friends, is the final answer. So that would be your answer, x minus 2, x plus 7. Okay, let's try another example. Okay, let's try this one here. 2p squared plus 14p plus 24. So step 1, check for a GCF. So I'm looking at my terms 2, 14, and 24. Is there a number that can divide into 2, 14, and 24? Yes, there is. It is 2. So my GCF is 2. So I'm going to factor out that 2, which means I'm going to divide all these by 2. So I'm left with p squared plus 7p plus 12. Okay, now I can list my factors of the c term. So c term is 12. So positive 12 over here. So that can be 1 times 12. That could be 2 times 6. That could be 3 times 4. Okay, so those are all my factors of the c term 12. Now I need to see which pair of factors will add to my middle term, which is 7. So I'm looking at the 7 here. Which one of these adds to 7? This is 13, this is 8, this is 7. So this one is the winner. 3 times 4. Now, my next step, I can bring down the 2 here. Don't forget to bring down your GCF. I'll write my 2 sets of parentheses. Now I'm going to take this term, p squared, and take the square root of p squared, which is p. So that goes here and here. And then I have, to finish up, 3 and 4. So a positive 3 and a positive 4. And this is the final answer right here. Okay, so let's practice this. So go ahead and switch over to your worksheet. And let's do some of these together. All right, let's start with number 1 here. Look for a GCF first. There's not one. So I can go ahead and pull this 48 to the side here. I'm going to list all the factors of 48. 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. All right. I've got all my factors. Now I can find the pair that adds to my b term, my middle term, my 14 here. So which one of these adds up to 14? This one right here. 6 plus 8 is 14. So this is our winner. Now I'm going to write my parentheses, and I'm going to take my a term, so p squared, and take the square root of it. So the square root of p squared is p. So that goes here and here. And then fill it in. Positive 6, positive 8, plus 6, plus 8. Final answer. All right, pause the video. Try 2, 3, and 4 on your own. All right, let's check to see how you did. No GCF here, so I'll pull this 16 to the side, and I have 1 times 16, or 2 times 8. I'm looking for the pair that adds to 10, so that's here. 2 plus 8 is 10. So that's my winner. Then I'll take the square root of n squared, which is n, so that goes here and here. And then positive 2, positive 8. Final answer. All right, number 3. No GCF again, so 40 here. I've got 1 times 40, 2 times 20, 4 times 10, and I'm looking for it to add to 14. Well, 4 times 10, if I add them together, 4 plus 10 is 14, so this is my winner. Sets of parentheses. Square root of p squared is p, so p times p there, and then plus 4 and positive 10, so plus 10. Final answer. Okay, let's check this one. No GCF, so I'll pull this 18 to the side. I have 1 times 18, 2 times 9, or 3 times 6. I need it to add to 9, so that would be here. 3 plus 6 is 9. Then I take the square root of the first term, so the square root of r squared is r, so r and r, and then positive 3, positive 6. Final answer. Okay, let's look at number 5. So number 5, no GCF, so I'm going to take the 7, and I'm going to list all my factors of 7. It's just 1 times 7, that's it. Now, this is a little bit different because I have a negative 8 here. 1 plus 7 is positive 8, not negative 8. So how can I get that negative 8 here? Well, a negative times a negative is a positive. So if I do negative 1 times negative 7, that's still positive 7. So negative 1 times negative 7 would be factors of 7. And if you add negative 1 plus -7, that's -8. So here's my winner, -1 times -7. Take the square root of p squared, so p and p, and then -1 and -7. All right, you try 6. Pause the video, try 6. All right, let's see how you did. No GCF, so I'll pull this 14 to the side. I can have 1 times 14 or 2 times 7. Go back here, I'm trying to get the pair that adds to -9. So that means all of these need to be negative here. So -9, -2 plus -7 is -9. So here's my winning pair. -2 times -7 is still positive 14, but when you add them, you get that -9 that we're looking for. Take the square root of b squared, so that's b, and then I have -2, -7. Final answer. Okay, so I'm going to have you finish up 7 through 12 on your own. So that will be your homework, your OTI on your own. Let's go down to this bottom section here. So we're doing the same thing, except for now we have GCF. So remember to pull out the GCF first. So let's look at 13 here. So I have 3, 21, and 30. So I'm looking for a GCF, the largest number that can divide into 3, 21, and 30. And that would be 3. 3 can go into 3, 3 can go into 21, 3 can go into 30. So my GCF is 3. I'll pull that out first. And then I'm going to divide each term by 3. So I would have r squared plus 21 divided by 3 is 7r, and then 30 divided by 3 is 10. Okay, but I'm not done. I still have to factor this trinomial here. So I'm going to bring down my 3. Don't forget to bring that down. GCF comes down with the answer. And I'm going to take the 10, pull it to the side here, and then I'm going to list the factors. 1 times 10 and 2 times 5. Then I'm looking for the pair that adds to 7. So that would be here. 2 plus 5 is 7. So this is my winner. Take the square root of this a term. So the square root of r squared is r. And then I'll fill in the rest. Plus 2 plus 5. Final answer. Okay, pause the video. Try 14 on your own. All right, let's check your work. So I'm looking for my GCF, so I have 2, 14, and 24. The largest number that can divide into 2, 14, and 24 is 2, so that's my GCF. So I'm going to pull out a 2, and I'm left with b squared plus 7p plus 12. Take my last term, 12, write down all my factors. So there they are. Looking for the pair that adds to 7. So that would be this one right here. 3 plus 4 is 7. So that's my winner. Don't forget to bring down your GCF. Bring down that 2. Square root of p squared is p. And then fill in the rest. Plus 3 plus 4. All right, you can finish these 4 on your own. So we're going to finish up this worksheet and submit your answers to Google Classroom.